chemical changes, we have to know they mean very different things. A physical change is just a change in the form of a substance, okay? Or it might even be called a change of state, right? There are the states of matter, right? Solid, liquid, gas. They are a change in state. It is not a change in its chemical composition at all, or there's no change in identity of the substance. Okay, so physical change, you might even write this off to the side. No change in identity. I couldn't remember how to spell identity for a second. Okay, no change in identity of the substance. Typically, physical changes are reversible as well. Okay, typically we can undo them. Not all, but most of the time physical changes are reversible. Okay, so physical changes are things like melting, boiling, evaporating, right? Freezing, all that kind of stuff, right? Those are all examples of physical changes. We can use to separate a mixture into pure compounds, but it will not break the compounds into elements, right? On physical changes, we can move things or manipulate things in a physical sense, but it's not changing their identity. Okay, do you know what any of these things mean down here? Distillation. Do you know what distillation is? To distill something, right? That's what that word means. What happens in the distillation process?
When it turns into vapor, you boil it, it turns into vapor, then it turns back into a liquid state.
Yeah, very good. Okay, distillation is essentially a purification process. Typically, you'll have distillation happens in alcohols a lot, right? The alcohol, they boil off. Let's start over. There's some sort of mixture of liquid happening, and in this mixture of liquid, those two substances have different boiling points. Okay, so they will put this mixture at a certain temperature, the lower boiling point of the two things. That substance will boil out of this skinny glass tube. It will become vapor and it will rise, right? And it will rise up this tube. And then it will use gravity to fall back down another tube and cool down and liquefy again and come down and be in a collection flask. So distillation has like a glass thing with some glass tubing at an angle, and gravity helps us get it back to a liquid again. But it's really an interesting process. It's essentially just a process of purification, right? It's almost like we're boiling out the impurities of our substance, right? Sometimes we want to collect what has been distilled, and sometimes we actually just want the original thing with the impurities boiled out, right? We can serve both purposes. But distillation is essentially a purification process. But we're not changing the physical thing. We're just separating that mixture. Right? We're not making something new. We're just separating out our two things. There's no chemical reaction that happens during that. What about filtration? What does that mean?
Well, filter out impurities, like charcoal, catches the impurities, most of the impurities.
Yeah, bingo, right? Just using a filter, right? We can be as simple as like a coffee filter or the filter that we used in class, right, to catch our sand. That filter paper works to catch solids out of a liquid mixture. Right? It can also trap other types of minerals and things like that. And then chromatography is a little bit different. It uses some light waves and things like that to look at some impurities and be able to get those things out. There was one other one I was going to talk about. Oh, a centrifuge. Do you know what a centrifuge is? Have you heard that term before? A centrifuge? It's a piece of lab equipment, and it's really interesting. It's typically used in like hospital or medical labs because centrifuge, what happens is you put most of the time blood or a sample in this little test tube, and it spins it really fast. Really, really, really fast. It spins it fast. And in that spinning process, particles will separate, right? And the solid or blood particles might sink to the bottom and other things float to the top, whatever. But it just literally separates that mixture that is blood or whatever they're testing, right? Whatever fluid it is that they're testing, but it spins it so fast that process kind of takes them out of solution, right? And separates those particles then by density and allows the lighter ones to rise and the heavier ones to sink. But that's kind of a cool way to separate things too, right? So we've got a couple different ways that we can look at how we separate things that or do a physical change. All right, a chemical change is when a given substance becomes a new substance. It becomes a new substance. That's really, really important. Okay, it becomes a new substance, and that new substance has different properties with different composition. Okay, so it is completely new. Different properties and different compositions. So in a chemical change, that means something new has formed. Okay, so they're given the example of burning something, right? A Bunsen burner. Do you know what a Bunsen burner is? That little stand, and it has gas that comes out of it. You light it. It's just a little fire, right? It's like a little propane fire, but we're not using propane. We're using methane or whatever natural gas we've got set up here. But it reacts with oxygen to form carbon dioxide and water. That's what happens in a combustion reaction, a burning reaction. We can't undo that. Okay, chemical changes are typically irreversible. Are typically irreversible. Okay, typically they are irreversible. Okay, on the next slide, you've got 4 things. Which of the following are an example of a chemical property? I want you to look through those 4 things and see if you can identify which of those is considered a chemical property. I'm not going to move my slide because it's got the answer circled, so I want you to take a guess first. Look on your next slide and say, of those 4 things, which of those is a chemical change?
State of matter.
That's right. We're physically manipulating the substance. We're crushing it up. Now, technically, could we undo that?
No.
Not really, right? We can't really undo that. We can't uncrush it, right? There's no way for us to do that. But is there a change in identity of this rock salt? No, we're just physically manipulating it. So there's no change in identity. So it is a physical change. I would agree. Dissolving of sugar into water. Physical change or chemical change? We know it's physical, but tell me why. Yeah.
Because the sugar isn't being turned into anything else.
Yeah, it's just now a mixture of sugar and water. So dissolving things, still just a mixture of those 2 things, right? Not a chemical reaction. It's not something new, right? What could we do to get sugar back to it by itself? Yeah, we would just boil the water off for long enough, and the sugar would eventually be left, right? And then it would become caramel, right? But it would just be what's left over. All right, very good. Melting a popsicle on a summer day. We know it's a physical change. How do we know it's physical?
Because the heat is melting the popsicle.
Yeah, and could we undo it?
Yeah.
Couldn't we just freeze it again?
Could.
We could, right? It's just still a popsicle, right? It's still that substance. Nothing new happened. Very good. But burning of wood, number 1, it's irreversible. We can't undo that, okay? And that's a reaction that those wood particles are reacting with. Methane and oxygen, all these things, and becoming carbon, like briquettes, right? Or charcoal, that's the word I'm trying to think of. Sorry, thank you. They're becoming all of that ash, right? Which is just carbon. And so it's not reversible at that point. What if I needed to sand something? What if I was sanding a piece of wood? Is that physical or chemical?
Physical.
Physical, right? Because it's still wood. Now the wood pieces are teeny tiny, but still at their molecular level are still wood, right? So I'm not changing that. I can't undo it. That's what an example of a physical change that's irreversible. I can't undo sanding, but I know that it's still just a physical change. Okay, here's kind of a little flow chart for you to kind of look at in terms of what is happening here, right? I have matter and I say, does it have a variable composition, right? And variable composition means, could its composition change, right? And if the answer is no, for example, water, will H2O ever be something different?
No.
No, right? So it is a pure substance. Okay, then I can say, does it contain multiple types of atoms? Yes, it is a compound that is a pure substance, right? We see that flow chart, how it works. Okay, yes, it could have a variable composition, it's considered a mixture. So if we could change its composition, that's considered a mixture. And does it have visibly distinguishable parts? It would be heterogeneous, and if not, it'd be homogeneous. So this flow chart gives us an idea as to what category matter can fall into. Okay, but it can go lots of different ways. Any questions there about chemical or physical changes? We feel good about identifying those? Okay, very good.